Awesome. Well, thank you all for giving thought-provoking presentations today. And it was quite fun for me to sit and reflect and see how it goes from digital fabrication to operational carbon to embodied carbon, and getting a whole picture of looking at sustainability from 3 different point of views. So I have a fun, quick question to start with. If our buildings could talk, if our projects could talk, whether it's a skyscraper or a cool project, what would carbon footprints brag about, and what would they admit that they need to work on? You want to start with Gene?
That's an interesting question. I think most buildings would probably, was it Lucan? I asked a brick what it wanted to be. It said an arch. I think if you asked a building what it wanted to happen with it, I think it would say, don't throw me away. We need to find a way to reuse, revitalize, re-energize the stock that we have. It's the lowest carbon thing we can do in terms of construction.
You guys want to take a stab at it too?
And there we go. I'll give the kind of obvious engineering answer, which is get real about the numbers. Like, don't just put a wind turbine on top of your building and say it's green. You know, what are the actual numbers associated with embodied carbon? I was at a conference a long time ago, you know, probably near the beginning of my career, where it was the Beijing Olympic Stadium was still in the news. And there was one of the kind of older structural engineers from the heyday of concrete shells, which are very efficient structures that don't get built much anymore, who said that he thought that building was a sin. Like, the embodied steel, the amount of steel used in that stadium is 10 times any equivalent stadiums. So, I mean, the numbers matter, guys. We're not gonna get real about addressing climate change to the extent our industry does, unless we really look at those.
Do you think moving to the performance-based solutions, talking about numbers, and you guys talked a lot about technology improving, design typologies, and how optimization is working? Do you think there's a shift for embodied carbon through that?
I mean, I'll say that I think we've gotten better at operational energy. Like, there has been kind of a focus on that over the course of my career, where it feels like people are talking about it, it's being improved, and that means that we sort of need to shift our emphasis to embodied carbon. And I'll be honest, I don't think engineers have been very proactive about, like, showing up at the green table. You know, like, we're temperamentally a little bit of a conservative profession and tend to kind of say, like, well, we'll do that when we're forced to do it. And that's not really the right attitude. Like, we need to be helping you guys, you know, put numbers in perspective, like, think about ways to solve the embodied carbon problem, and really inform new architecture. I mean, there was this shift to high modernism that still informs a lot of our architecture around Chicago that was powered by industrial production and fossil fuels. I mean, what is an appropriate architecture for an era of reduced embodied carbon, right? Of addressing the climate crisis. We don't know what that looks like yet. I think we need to figure it out.
I do think Zainer's taking a great stab at it. Honestly, I love all the projects he showed, looking at metal that is recycled and, bringing back the sexiness in architecture, if I may. Any thoughts on that?
Yeah, well, I was more interested maybe in the first one of revisiting that, just in terms of buildings and their future, thinking about themselves of what's my life after maybe this first use of, and how do we think about designing for, with so much energy and so much time goes into core systems, but what could a building be reused and retrofitted for, and how do we think about that as changing designs, and then all these digital assets that can also then be pulled into the future, kind of have that buildings continue to have transformations and what that looks like. One of the things that I think a lot about in terms of how, the notion that, like, metal can be fully recycled, so could a building, parts come down, be recycled, and then used again to retrofit in a new form.
And look good. So one of the biggest, so we do have PV technology. 70% of our energy today is renewable. We have different other forms of technology coming up. I do see that one of the biggest challenges is scalability. And how, as architects or engineers, or how can we try to take a stab at the challenge of scalability? Or what do you think could be the change about that future?
The scalability piece is really interesting. You could take sort of an extreme example of that today, and that would be Neom the line, and the idea, let's find a way to build a city for 9 million people as a single contiguous structure. Is that the right answer? I'm not sure, but it's an interesting approach as a way to think about that. And so the issue of scalability, if you think about most buildings, they are unique objects. They have all of the same elements, but the aesthetics are unique. The program is unique. The people that work in there are unique. The businesses are unique. I think that's a great value. So I'm less sort of concerned about scalability in terms of repetition. I'm interested in terms of scalability, in terms of the adoption of technology and how quickly, what is that technological curve? If you think about for how uncounted millennia, our lighting source was a fire. And then we went to a candle. And then we went to a whale oil lantern. And then we went to an incandescent, and then a fluorescent and a compact fluorescent with a little side detour for some halogens to where we are today with these amazing LED fixtures that we have in that space. What's next? What does it take to get from that fluorescent bulb to the incandescent bulb?
You want to take a stab at it?
Well, I mean, it's an interesting question from the perspective of embodied carbon. I mean, one of the kind of unique constraints of structural engineering is there's only a few materials we get to use at scale that are affordable for large scale building construction. It's timber, steel, and concrete, and I guess masonry. But, we're very constrained by the scale of our buildings to find things that can affordably build with. We don't really get to use carbon fiber very much, right? And, that very limiting palette of materials is something that I think kind of advocates an optimization approach. It's like you're kind of stuck. There'll be some improvements to embodied carbon and concrete. You can recycle metals, right? You can recycle steel, but it's not going to necessarily happen at the level of material innovation. I don't really know that that's something that I could realistically say. So there's other mathematical techniques of how do we, and really architecturally informed kind of design techniques, how do we end up with something that really uses less material as a whole and hits the same performance targets? I'll give an example of that. Our concrete floor slabs for buildings are very stupid. Like most of that concrete is cracked. Reinforced concrete floor slabs are an incredible waste of material. And there are vaulted ceilings that have been used, to support weight in historic masonry that are considerably more efficient that we don't make use of just because it's easier for a contractor to put down a flat slab, right? I mean, there's a shape element to this where if we were able to use shape better in our buildings, right, we'd be able to cut a lot of material without necessarily relying on a material breakthrough to get us an embodied carbon reduction.
So it's less about, it's also about materials, but it's about how you use that material and how can technology move and shift that? Is that a good way to sum that up?
Yeah, and how does that get embodied in architecture? There's this kind of adoption curve where, we're used to doing things a certain way, and things that aren't that way look weird or feel wrong. And to a certain extent, I think for people in here who are interested in innovating, you need to keep showing people the same new things over and over to get them used to it, right? And you need to kind of make that case over and over again. But, there's limits to that. Like I made a polemical point in my talk that there needs to be a mandate for this to really move. I think there'll be a lot more receptivity to new architectural solutions if there actually was not just a per project incentive structure for reducing carbon, but like some of the things we're starting to see with the UK legislation, right, that are pushing towards less embodied carbon as a mandate.
Nathan, I was very impressed by one of the slides you had, which was best practices, but also mentioned about the human and robot collaboration, and especially with AI come in. Where do you think is this going to take us to, with all the digital optimization, robots working, is this going to take us to a new style of sustainability architecture, or where do you think this could be going?
Yeah, I was really inspired kind of by Martha's presentation and the way she talked about that line of what does creativity become? Because some of the same questions of um, as the traditional craft of working with a material and all that embedded expertise, how much of that do we extract and pull out and try to digitize, and how much of it stays there, and what becomes that line in terms of delineation? I mean, it makes us much more efficient, you know, in terms of being able to offload and get things and gives us the ability to execute on things faster. But then we also lose, I think there's certain components, and we're very interested at how do we navigate that line and continue to move the things that make sense while still celebrating what the human brings to it. And I think that's, you know, for us, like we will want to build a future that we want to live in. And so I think that's continually how we're asking ourselves that question of like, how do we bring in that technology to use?
So we want to live in the future we want to build in. Talking about that and through the lens of a dry topic of regulations, I want all of you to take a stab at regulation governs how we build and what we build, and we are kind of through our through your work understanding how it can be more sustainable, but it still shapes a lot. What you know individually, what do you think when you reflect upon regulations while you work?
I think for me, I think back to sort of the beginning of my career and how we delivered projects and how we deliver projects today. And I think about all of you thinking back 35 years at the end of your career, where we're going to be in 35 years in terms of all of this. I think we are going to see a very intensive AI-based digital construction and design integrated process that hopefully we're taking the most advantage of the materials and the limited resources that we have to provide very efficient designs. So I think right now, all of those elements are developing their stovepipes. They're starting to connect to each other. What I see is the integration.
Integration. Nathan?
Yeah, I mean, I was just going to kind of pick up on that. The integration, you know, right now, so much of the industry is scattered across, you know, in terms of costing structures, the way things actually get valued and how we evaluate things. And so I'm very optimistic about that technology being able to help unify the field in some ways so that there's more transparency to areas and help to highlight things that are purposefully hidden on projects, you know, to hold on to and slide under the rug. So.
Thank you.
I mean, I'll give an example that Mr. Dean kind of brought up in a conversation with me before this meeting, which is in seismic design of structures in California, you can do performance-based design, right? If you were to do a prescriptive seismic design of a building in a high seismic zone, it would be absurdly expensive, right? So this is kind of a type of process that still gives you a rigorously safe design, but allows you to use the latest technology to achieve a target of seismic safety. I think we need something like that for carbon, you know, a performance-based embodied carbon target, right? Where there's still a rigorous review process, so you're not cheating the system, right? But that you can use the latest technologies. I mean, there's a problem with prescriptive codes in structural design. There's a problem with prescriptive codes in energy design, where you just can't capture how things are going to evolve. But you don't want it to be a free-for-all either. There should be a target, and how you get to that target can be dependent on the latest technology. I don't think we're there yet, but I think that's a good model to kind of look at if we're talking about, you know, hitting mandated embodied carbon targets.
So we're definitely missing some of the rigor. With that, I'm going to open the floor for any questions from the audience, virtual or in person.
For our work, what we typically do is we take the models from the structural engineers, and it's a conventional calculation. It's relatively simple. It's the dumb Excel spreadsheet. But what we're able to do is out of the models is extract the information out so that we can very quickly calculate that. Before, we would have to measure every beam, every slab. Tedious manual work to answer that question is now automatic in a good 3D model. And then it's super simple to dump it into just an Excel spreadsheet. The other thing that we do then is we evaluate all of the various carbon options around the material. So we'll typically do a baseline, we'll do a proposed, looking for all of the things we can do. For instance, really high performing concrete, sometimes very high strength concrete where we can thin up the structure, develop a series of options. That's the feedback loop that we would have with the structural engineers to optimize those design components.
Yeah, for us, it's heavily reliant on sort of the established industry analysis, and it makes it difficult with advances in terms of through a process saving, be able to quantify. And we're relatively small operation, and so the tools and the ability to actually look at those things and quantify them haven't, I think, caught up yet. And so that's something we're actively trying to understand and figure out of how do we bring unjust quantify that sort of value that we bring to the process. But I think it's still problematic because you don't want to rig the system and, you know, in unfair ways. You want to, how do you unbiased do that, but also not bringing in some at the scale of what a large company can bring into quantify.
I'll take that in a slightly different direction in that, you know, kind of like Martha was talking about in our talk. Approximate information early on is a lot more important than detailed information later. It's kind of too late if you're doing a detailed embodied carbon calculation at the end of your process. So yes, it's just an Excel spreadsheet, but what you really need to be doing, and you know, I've certainly learned a lot doing, is trying to identify the key variables for design that you have control over early on. And it really is shocking how different embodied carbon is from cost. I mean, one of the things that I found I did not appreciate until I ran the numbers through sort of an optimization routine when I was looking at early design is the percentage of recycled steel is almost the most important variable. If you're using 100% recycled steel, you'd barely ever touch concrete. If you're using 100%, you know, virgin steel out of US Steel in Indiana, your entire building would be concrete. There are some key driver variables that you can identify and kind of try and control as much as possible in your design early on without kind of getting lost in the details of a embodied carbon calculation, which is just kind of too complex to incorporate into the design process a lot of the time.
That's very insightful. I think that is one huge takeaway is have approximate values before, understand what direction you're going into, and sharpen your axe before you go for it.
I don't know that this is like industry-wide knowledge necessarily either. Like, I feel like we're still kind of disseminating what's the important design driving variables for embodied carbon. You know, there's a sort of education and discovery process that has to happen here.
We'll take one more question.
And as it happened, we were collaborating with Bath University, and we did the research around that particular model. And what stopped further revision was what happened there are so many things that need to be regulated in particular bylaws or directed to government or even within finances that can finance that. So even if the architects and the engineering let's say the regulatory framework that supports the plan to come, and as we plan to build as a part of the plan, all of this becomes wishful thinking somehow, which is
I will say there is a company that is doing code compliant vaulted floors.
sounds like a traditional, traditional is any action that it doesn't take. That's so hard to shift, like the Titanic, right?
Yeah, I mean, people like to complain about regulations, but the only thing we're small potatoes compared to construction. And the only thing that's really big enough to kind of shift that needle is government. So I think we should think about how we would want to lobby for regulations that are reasonable, like a performance-based standard, something that gives us the flexibility to design, but that still tries to hit a real target. Because I don't know that we can individually make construction firms take these things seriously. Like
Yeah,
we've all had that struggle.
The other thing I was going to add to that is it is about seeking out the innovators. I mean, we have to do that. Nathan's firm as an example of, as an innovator in terms of how they're producing a product. So we as designers need to be looking for those firms, for those products, those systems. We also need to be looking for the contractors that are the innovators. And we need to be looking for the suppliers that are the innovators. That's, I think, where it's going to be incremental change. We all didn't start out doing CAD. There was a long, rocky road. And what we saw was that very quickly, people realized, hey, the other guy's doing it. Maybe I should do it too. And it's that, you know, the early adopters are the leaders. They're also the risk takers. But risk taking in construction is a lot harder.
It seems like what Martha was saying, there's some sort of fine tuning going as we understand more and you know, we kind of get a better direction as we move forward. So to wrap up the session, I have a one last question to wrap it up. I'm going to call it as if you had to give the audience in one word, one hashtag, how should they think and approach sustainability once they go back to their desks? From each one of you, what would that be?
I feel like I'm under the gun here, microscope. One word, sustainability. I think innovate. We know what sustainability is. We know how it works. We know what to do. We need to do it, but we need to look for, we do all the prescriptive things. That's easy. We need to look innovatively at how we do our work.
Innovate's a good hashtag. Nathan?
Collaborate.
Collaborate, innovate, collaborate. Toby?
I mean, I'll go with honesty. Like, I think that there's something to be said for like the old modernist ethos of building buildings that are kind of appropriate to industrial production. What does that look like now in the digital era, in the era of like constrained resources and embodied carbon? Like, what would be an honest low carbon architecture?
Wonderful. So honesty, innovation, and collaboration. Thank you so much. What an insightful conversation and deep dive into carbon and sustainability. And I'm taking away a lot of cool things. Thank you so much, guys. Appreciate it.